First question. So you can probably listen to this question all together before you start doing it. So the aircraft is flying with a heading of 200 degrees. If nothing much is mentioned, you can go with the magnetic value there because that's what it's there in real. After flying for 180 nautical miles on this particular heading, an aircraft's ADF reads 186 degrees. So what is the ADF reading? 186 degrees. If the remaining distance to go to destination is destination is 120 nautical miles, you're asked to find a series of values here. So what is the total distance to cover? It has already covered 180 nautical miles, and there is a further 120 nautical miles, bringing it to around 300 nautical mile journey. So after traveling 180 nautical miles on a heading of 200, the pilot realized that its ADF is reading 186 degrees, right? It's pretty obvious since you're moving away from a particular station. So the NDB, the ADF is still tuned to your departure NDB. That is why it is showing you 186, right? Perfect. Now, one thing which I want you to understand, particularly from an ADF reading, we have seen that before. So any ADF reading should give you two different information instantly. You should be very, very clear on that. Number one, when you see an ADF reading of 186, what are the two things which you can derive from this? Two information which you can derive.
Moving away from station.
You're moving away from the tuned station, right? So you're moving away. Yes. What else?
And the drift.
Yeah, what's the drift here?
6 degrees starboard.
That's right. Drift is 6 degrees, and since it is 180 plus 6, it's more like starboard drift. Now, how will you read this? From where will you read this 186 degree? It is read from the RBI, which is there in the cockpit. Well, we saw the 6-pack instruments. The seventh one was the ADF, right? So this drift is more like an actual drift. The actual drift experienced by the aircraft currently read from the instrument. So whatever the instrument is giving you is the actual value. The indicated values are all the actual value, not the value which you planned before the flight. So before the flight, you always plan something called as a planned drift. And that is the angle we saw yesterday, which is between heading and the planned track. But what you read from the ADF is not the planned drift. It is the actual drift experienced based on the actual wind and the heading which you're flying. Therefore, this is more appropriately the actual drift. So this is one thing which you have to particularly understand. The information, the drift that you read from an ADF indication given in the question is always the actual drift. Now, why is this significant is that for a given heading of 200 degrees and an actual drift of 6 degrees starboard, what can you derive from this? Heading and drift?
So the track is starboard of heading.
That's right. 6 degrees starboard drift means your track is 6 degrees starboard of your heading. Therefore, what is your track?
206.
206, because it is to starboard. 206 degrees magnetic is your track. Now, what track is this? Since I have derived it from the actual drift, this is the actual track. The actual track flown by the aircraft, not the planned track. This is not the track this probably might not be the track which you want to fly. This is the track currently flown by the aircraft. You see, we have seen planned track and the aircraft going somewhere else. This is the actual track. This is the track which you're going to get because the drift which you're applying to the heading is not the planned drift. It is read from the ADF and therefore to the actual drift. When you apply actual drift to the heading, you will get the actual track. What is the other name for actual track?
Track made good.
That's right, the track made good. This 206 degrees is the actual track or the track made good. Is that clear so much? So the ADF indication has to give you two different understanding immediately, and always a drift, one is the direction, other is a drift. Now the drift read from the ADF is always the actual drift, and therefore when you apply the actual drift to the heading of the aircraft, what you would get is the actual track flown by the aircraft and not the planned track. So be very, very clear with that. Now why do I need track? Because if I want to draw anything here, what I need is track. I cannot draw things with heading or wind and stuff. To draw a line, I need a track. So what's the track here? I got the track as 206 degrees. Let's draw a track of 206. A track of 206 is somewhat in this direction.
Yes.
Right? Let's put the NDB in the center. the NDB to which the aircraft is, the ADF is tuned to. Now, where will I place the aircraft? Right side or left side of the NDB?
Left.
Left. Why? Because we are moving away from the station. On this track, the aircraft has to be placed here, right? So let's place the aircraft. Now, where can you place the aircraft? Is it sensible to place the aircraft? What track is this? This is the actual track or track made good. Remember, the aircraft can be always found on the actual track, not on the planned track. If your planned track is equal to actual track, well and fine. But otherwise, if you are going to search for the aircraft for rescue purposes, you have to go through the actual track of the aircraft, not the planned track, because you might not be able to fly the planned track. Right? That is why it is very important that when you make deviations in your track, you have to inform the ATC as against your flight plan. So when you make diversions, you have to call them and you have to tell them that I am diverting, because in the event of a search and rescue, if you don't tell them that you have diverted and gone somewhere else to see your girlfriend here, they probably will go all the way tracking from straight till here, will not find you, and they'll kind of take much longer before they find you somewhere completely different. Right? You might survive the crash, but waiting, the environment might kill you. So it's all a thin line there, right? So basically, if I want to find the aircraft, I would simply track through track made good, not the actual track. Therefore, if I want to place the aircraft, I would always place it on track made good. Now, to place the aircraft, I have to look at the heading. What's the heading? 200. This is 206. Therefore, the heading, moving away from the track, the heading of 200, the aircraft should be in this orientation, right? Let me put the aircraft here. So the heading of the aircraft is say 200 degrees. Right, now what are you asked to find out? So we have put all the information, we have drawn a diagram here. You're asked to find out A, find the new heading to the station. So you see, if I draw a simple diagram here, so NDB A, and you're moving to another aerodrome which is here, and you have a VO1 or another NDB here. What track is this? Connecting these 2 points, your departure station, destination, this is the actual track, the track which you want to fly, and therefore that is your plan track. The track which you plan, say Bangalore, Chennai. This is the plan track. But because of wind, inaccuracies in navigation and stuff, you might end up going like this. This is your actual track. Right? So where can I find the aircraft? I cannot find the aircraft on this. I'll be able to find the aircraft only along the track made good, the actual track, because of the track flown by the aircraft. Right? But where will be, so starting from A, I have 2 tracks now. One is the track made good where I can find the aircraft. Another track which is a planned track where I can find my destination aerodrome. So if I want to find the destination aerodrome, I should not be looking on the actual track. I should be looking on the planned track. Do you understand what I'm trying to say? To find the aircraft, I have to look up the track made good. To find the destination aerodrome, I have to look at the planned track. Right? So in this case, the aircraft flew a track of 206, and this is a track made good. This need not be the planned track. And as long as you cannot find the planned track, you will not be able to locate where your destination aerodrome is, because destination aerodrome lies on the planned track. So what I need here is a planned track. How will I find the planned track? The track which I intended to fly. How will you find that? If I have track made good, track error is required to find the planned track. Very good, because track error is the one that connects your planned track with the track made good. So what is track error? Is the angle between planned track and track made good measured from the planned track. So I have the track made good here, which is 206.
06.
Neither track error nor planned track is available. So which means I have no way to find the planned track, because I don't have the track error also. I don't have the track error. Right? Make sense? Now let's look at the ADF indication here. What is the ADF indicating? Tuned to this NDB. This is 360, 180. What is it indicating? 186. Therefore, what is this angle here? This angle is 6 degrees. What is that? That's the drift. We have a 6 degrees of starboard drift here, which we already have. Heading, track starboard of the heading. So in this case, to find the planned track, I want track error. To find track error, I want planned track. So it's a bit of confusion there. So we don't have any other choice but to assume one of these. Right? So here, we'll come back to the details a bit later. Here we assume that your planned track is equal to your heading. Now this is a classic scenario where you will have a solid or a very prominent drift. What's the meaning of this? When you fly a heading equal to your planned track, what happens? So when can you fly like that?
That's basically that's a nil wind condition.
You can accomplish the planned track in such case only if there is no wind. Otherwise, what happens? You will drift. Right? Therefore, if I assume planned track is equal to heading, what is my planned track now? My planned track is equal to heading is equal to 200 degrees. Now we will come back to this point again and we will see why we have taken this. So now I got my planned track. What's my planned track? My planned track is 200 degrees. Now where will I locate that? 206 is here. So 200 is here. Now see, I'm trying to draw a line like this, which is 200, because my planned track is equal to my heading. That is why I have drawn it like this. That is exaggerated, but just to make you understand. Your heading is equal to your planned track, which is 200 degrees of planned track. Now you see this situation here. I was supposed to take off from here and fly a track of 206, but since I did not cater for the wind and I started flying my heading equal to the planned track. So what's the planned track? All the way the plan. So this is the planned track. I'm supposed to take off from here and fly like this, all the way. So where can I find my destination aerodrome? On the actual track or planned track?
The planned track.
On the planned track, which means my destination aerodrome is going to be somewhere here. This is my destination, this is my departure, and I'm supposed to fly this planned track. But since I did not cater for wind and I kept a heading equal to my planned track, I drifted off. And this is what has happened. And I eventually reached here. So you can see that it's more like a wind coming from this direction, from my port, pushing me to starboard.
Yes.
Right? Got the scenario here? Now, what can you say about the drift here? From the
60.
Heading towards the track made good, your actual drift, because it is track made good, is 6 degrees. What can I say about the track error? Track error is the angle between planned track and track made good measured from the planned track. How much is it? 206. This is 200. Therefore, 16 degrees. Since your track made good is to your right, it might look left for you, but think about the aircraft, it is towards your right. Right? Therefore, it is 6 degrees right. So when you took your planned track equal to your heading, what happened to your drift and track error? Your drift now becomes equal to track error. So if I maintain my heading equal to my planned track right from the beginning, my drift and my track error, my actual drift and my track error will be the same. Because my heading is equal to planned track. So the angle between heading and the actual track is simply equal to angle between planned track and the actual track. It's the same. And therefore it is 6 degrees. So since when you assume planned track is equal to heading, we can also say that your drift, actual drift is equal to track error. Understood? Otherwise, there is no way you can find the planned track here if you do not take the assumption. So I assume that I did not consider the wind and started flying a heading which is equal to my planned track. And I got drifted off, therefore my drift is equal to the track error. So track error is equal to drift. Now what is my drift? Drift is 6, therefore my track error is also 6. Does it make sense?
Yes.
So how long did the aircraft travel? If you freeze the question, the aircraft has traveled for 180 nautical miles. And for smaller angles, we know that this is the actual distance traveled by the aircraft, which is 180. But I can also take this as 180 nautical miles, since the angle is smaller. We have seen that before. The larger the angle, that is why we say more than 20 degrees, your 1 in 60 will break down. Because you cannot take these two sides as equal. Therefore, when you say distance gone, it is exactly this distance, and that is not going to be equal to this. I'll show you this once again. If you take smaller angles, these two distances are relatively same. You might have a small difference, but that is fine. As you come closer, you see, for larger angles, you cannot take these two sides as same. there can be a larger difference, and you might end up having it. That is why 1 in 60 breaks down above angles of 20 degrees, and we have seen that, right? Only for smaller angles we can take these two as same. All right. So now, what is asked the question? How far? What is the distance of destination from here? It is again
120.
120. So the destination is 120 nautical miles now, not from the departure, but from this point, right? Now you're asked to find out. What are you asked to find out? Find new heading to the station. So now you're here. Now, if I want to track towards destination, I have to fly a track like this. This is a new track to destination. You're asked to find out what is the new heading required to fly this track. Now you can find out. This is the part which is a bit trickier, which you need to know. Otherwise, do not assume this as a planned track, because this track made good. Right? Analyze this once again. I'll give you some time to actually digest this. If you have questions, ask me, I'll even explain it. That's fine. Yeah, you have to first find the distance off here. So what is asked in this question A? You're asked to find out the new heading. So any given question, if track heading is asked, always define the track first. Find what is the new track, because once you get the track, you have the drift and you can find the heading, right? To find the new track, you can apply 1 in 60. So if you look at this distance here, this is the distance off. And what is this? This is the distance gone. Remember, the actual distance gone is this. That's what I told you before. Since the angle is 6, this 180 can be taken as over here as well.
Yeah.
So this is going to be 180 nautical miles. We have the track error, which we found out eventually, and then distance off. So applying 1 in 60 here. What is track error?
Like degrees is equals to distance off by 180, that is distance gone,
Into 60.
multiplied by 60.
So 6 degrees is equal to distance off, you have to find out. My distance gone is 180, this here. Nautical miles into 60. How much is that?
It is coming 18 nautical miles.
18 nautical miles. So you see, 1 in 60 says that if you have a track error of 6 degrees over 60 nautical miles, your distance off is going to be 6 nautical miles. So over 60 plus 60 plus 60, 180, it's going to be 6 plus 6 plus 6, and that's 18. So you don't probably have to use this equation. Even without that, you can find out. So this distance off is going to be 18 nautical miles. Right? Now we got the distance off here. Now we can find out. So the whole idea here is you have to find out this track here. Right? So yeah, so if you can apply 1 in 60 here, what will you get? You will get the angle over here. And what angle is that? That's the closing angle. So what's the closing angle? Distance off
That is
by
my distance to go to 60.
into 60. Right? Yes. So closing angle is equal to, what is distance off? That's 18 nautical
18
miles.
by 120
120
to 60.
into 60. So
That
again,
is
you can
9.
see that over 60 nautical miles, 18 nautical mile distance off will give you 18 degrees of closing angle. So over 120 nautical miles, it's going to give you half of that. Right? So how much is it?
9 degrees.
9 degrees. Yes, Deepika, Apeksha, all the ladies catching up. So now what is the use of finding these two? You have the tracker now, you have the closing angle. What are you trying to find out? The new track. How will you find the new track?
So we have 6 degrees here,
And 9 degrees here. So what is the current track of the aircraft?
right? And that angle will be
206. So what I'm going to do is I'm going to take this planned track and I'm going to draw a line that is parallel. But fortunately,
Parallel.
the heading itself is parallel to the planned track, because you've taken heading is equal to planned track. So that line is going to go straight in line with the nose of the aircraft.
yeah.
Right? So you have two different angles here. The first angle is exactly the same as your track error or the drift. Second angle is exactly equal to closing angle. So what's the total track change?
15.
Is equal to 6 plus 9, which is 15 degrees. So if this is 206, 15 degrees in the anti-clockwise direction, what's the new track? 206 minus 15, right? So
191.
new track to destination B is equal to 206 minus 15. How much is that? 19. How much is it?
191.
191 degrees magnetic. Now, if you have the track, how will you find the new heading?
Wherein the
Track
accelerator
change is equal to heading change.
Heading change. Two different methods to find this. One is we can apply track change is equal to heading change, or you can simply apply drift to this track. So what's the actual drift? 6 degrees starboard, which means the track is starboard of the heading. Therefore, what is the heading?
So the current heading is 200.
Yeah, and you can subtract 15 also. That's also correct.
Subtract what?
15. 15 is the track change required.
For the new heading?
Yeah. So what I'm doing here is I've taken the new track because you told me it is 191. I've applied the drift of 6 degrees starboard. So what is the heading?
So drift is starboard, so
Yeah, 191 minus 6. Oh, I thought it was
Drift is starboard, so the heading is less than track, right? That's what we call starboard drift. Track is starboard of heading. The heading is less by 6. So what is 191 minus 6?
185.
185 degrees. Now there's a second method to do this, where we assume that track change is equal to heading change. Not assume that, it is correct. Track change is equal to heading change. Let's see that. So change in track, can you read this?
Oh.
Can you read this? Yeah, you can read.
Yes.
Track change is equal to heading change. What is the track change here? 15 degrees to left. Therefore, what is the heading change? Heading change is also 15 degrees to the left. What is the current heading of the aircraft? Current heading of the aircraft is 200. 15 degrees to left means 200 minus 15, which is 185. So you can find out the heading, new heading, by applying this concept of track change is equal to heading change and applying it to the old heading. Or you can find the new track, apply the actual drift, and then also it's the same thing. There's nothing different. So the aircraft is on a heading of 185 degrees. If it wants to track 119 towards destination with this drift. Understood? And then that answers the next question also. What is the new track to destination?
One more.
191. Yes, the new track destination is 1. We applied 15 degree track change to 206 and we got 191. And what about the third question? Track required from the place of departure. What was the actual track that the aircraft should have flown to reach destination? Is the planned track, which is 200. The aircraft should have actually flown this track, but since it did not cater for the winds, it went on a different track of 206. So what is the actual track from the departure station? Is 200. Because we assume that the planned track is equal to heading, and therefore we assume that the drift is equal to track error. Make sure you note this. If heading is equal to planned track, track error is equal to actual drift. That idea is required to start this question. Otherwise, you'll end up just circling around the same thing.